All right, good morning. Welcome back. Happy Wednesday. Starting on page 227 in just a minute. Let's take our quick look at the calendar. I have a little bit to say about the test, but I will say it when more people are here. So just looking at the calendar, there's not much left. This is the entire calendar up on the screen here. So today we are starting a brand new topic. And this topic is going to take us for the next 4 days, and it's the rest of the new material. What's the word in common on those 4 days? Fractions. You said UG, but there's no UG in here. The word is just fractions, not UG fractions. So what we are after for the next 4 classes is stuff on fractions, okay? The things that make what we're doing here different from the fractions that you know and love is that the fractions that you have a lot of experience with are just fractions with numbers in them. But what we're going to be talking about for the next 4 classes are fractions with variables in them. So we're going to see x's and y's floating around in our fractions, okay? All right, so that's the plan for the next 4 classes. And we've got 1 quest left. It is on May 13th. Somebody tell me what day is that? 13, is that Friday next week? Yeah, next Friday. Okay, so our 5th and final quest is on Friday next week. It is on just the 4 classes on fractions. Then we've got 1 review day on the Monday coming up, a week from this Monday, I should say. And then the final exam is 2 weeks from today, gang. We will be here before you know it. 2 weeks from today is our final. It is on everything for this semester. Okay, so starting here again on 227. In this lesson, we begin our work with algebraic fractions or rational expressions, including simplifying them, multiplying them, and dividing them. The next 2 classes, we will take care of adding them and subtracting them. Today's demo is long, so we're going to move kind of quickly. Here are some examples of algebraic fractions. What's different about these fractions from the normal fractions you have a lot of experience with? They have variables in them. That's all, right? And so we are going to, at number 2 here, it says we're going to evaluate these fractions and we're going to simplify them and we're going to perform the operations of multiplication and division and addition, subtraction, just like we do with ordinary fractions involving only numbers. But of course, the difficulty is ramped up because there are variables in play here. All right, so number 3 talks about reducing this fraction 24 over 54. So every time we do something new with these fractions with variables, we're going to first remind ourselves, how did it work when the fractions had just numbers? And it's going to work exactly the same way when they're variables. So what number goes into both 24 and 54? 6 goes into both, right? 24 is really 6 times 4. So 24 has become 6 times 4. 54 is really 6 times 9. And then once it's written that way, what can you do to simplify it? What can we cross off? The 6's, right? Because it's the same 6 on top and bottom. And we're just going to go a tiny bit in slow motion here and say, okay, you guys know how to multiply fractions straight across, yeah? No common denominator for multiplying. You just multiply straight across. So if multiplying straight across is how we multiply fractions, then would you believe that these 2 things are equal to each other? So if I gave you the right-hand thing, you would just multiply straight across and it would become the left-hand thing. So those guys are the same. And now that I see 6 over 6, what is that really equal to? It's really 1. And so again, really going slowly here. This is why you can just cross off the 6's, is because you're allowed to peel a 6 over 6 off of the fraction. 6 over 6 is just 1, and multiplying by 1 doesn't have any impact. And so that 1 times doesn't do anything. You just get the answer of 4/9. All right? So I know that this is more details than normally you would think about if I asked you to reduce, but it's important that we understand what's making this thing work. Now that 6 over 6 is just a fancy form of 1. Yes? And there are lots of fancy forms of 1. It didn't matter that it was 6. It mattered that it was the same number on top and bottom. And so we're going to see these fancy forms of 1 over and over and over again. So we're going to use this acronym FFOO, fancy form of 1. That's hard to pronounce in its current form, so we're going to cheat a little bit. And we will call it a foo-foo, fancy form of 1, okay? All right, so let's take a look at number 4. Are we allowed to cancel the 2's in this first fraction? Yes, because you see multiplication, and in your mind, you could run through the same process we just did. You could pull the 2 over 2 off of the fraction, and 2 over 2 is just a, it's fun to say, foo-foo. So we can just cross it off. So the answer to this one is just 13 over 3. The next one, 13 plus 2 divided by 2 plus 3. Same problem, but just additions instead of multiplications. Can we cross off the 2's? If we can, it isn't for the same reason that we could up above, right? Because this is not multiplication. And so, well, let's just see. I mean, what's the right answer? Up on top is really 15, downstairs is really 5. So the right answer for sure is 3. And if you do anything that gets you something other than 3, then you must not have done things that were okay. So can you come up with any way to cross off the 2's and somehow see the final answer of 3 looking at that thing that's left? I can't. There isn't a way. You just can't cross off those 2's. How about in part C here? I see same problem, but subtraction now. So for sure, the right answer is 11 over -1. If we're allowed to cross off the 2's, can you somehow see the answer of -11 in what's left? I can't either. So the moral of the story is you can cancel provided the operation is multiplication. You cannot cancel when there's addition. You cannot cancel when there's subtraction. We're going to say that a lot. Okay, so the thing that made this example right up here work was that we first took the number 24 and the number 54, and what did we do with those numbers? We broke them down. Let's use one single word that means turn into multiplication. We factored, yes? That's what made it work. We took 24 and we factored it, meaning turn into multiplication. And we did the same thing with 54. And once it was multiplication, we pulled off our foo-foo and we canceled. So the first step, even when we're down here with simplifying things with x's in them, is to factor. It is really tempting to start canceling because there's a lot of stuff that looks similar in top and bottom. What might we be tempted to cancel? X squared, it's the same on top and bottom, right? What else might we be tempted to cancel? 9, it's the same on top and bottom. Look, I'm in pretty good shape and my heart is pretty strong, but don't do this. You're going to give me a heart attack if you do this. You cannot do this because it's addition and or subtraction. You can't do anything because it is not multiplication. So we ask ourselves this question: are the numerator and denominator in factored form? The answer is no. So if they are not in factored form, we put them in factored form. All that time we spent factoring, we're going to continue to use as we factor numerator and denominator completely and separately. So big fraction line. Just reminding us of the process for factoring. First kind of factoring always is the greatest common factor. Upstairs, what is the greatest common factor of x squared and -9? It's just 1, so we can't do anything there. Next thing, is it a difference of 2 squares? That one is a difference of 2 squares, so we're good to go here. Let's write our parentheses. X squared came from x and x. 9 came from 3 and 3, and then 1 plus and 1 minus in either order, and it's factored. The bottom is a completely brand new factoring problem for us. X squared plus 6x plus 9. Greatest common factor, what is it for those 3 terms? It's 1, so we can't do anything there. Is it a difference of 2 squares? Nope. So the last kind of factoring is the 2 by 2 box. And you would do it. Now, some of you guys are really quick at the 2 by 2 box. Some of you are a little bit slower. As long as you get there, it doesn't matter really what your pace is. You'll have time. But we're just going to kind of zip to the punchline here, and you can fill in the gaps later on. But if you do the 2 by 2 box method in your own time, you will get x plus 3 for that one right there. And we're going to do this a few times today where we just skip over the details, but take your time as you're working through the activity and the homework. Now, the top is in factored form. It is a multiplication problem. It's true I see additions and subtractions, but at its heart, that is a multiplication, yeah? And this is also a multiplication. So we're in factored form. And if you are in factored form, you are looking for foo-foos, fancy forms of 1, things that are exactly the same on top and bottom. What's exactly the same on top and bottom? the x plus 3, and you just cross them right off. And it might seem like we contradicted when we said you can't cancel when it's addition or subtraction, but it's not addition or subtraction, it's multiplication. The red dot there is multiplication. And this thing here is, it's in parentheses. And if I just kind of blur my eyes a little bit, I don't get distracted by what's inside. The important thing is not what's inside. The important thing is it's a copy of what's inside down there. Right? So it is multiplication, even though inside it's got addition. So our final answer here, just copying what's left, we don't need parentheses anymore. We get that. Okay, and now we've got this. I see x on top and bottom, so go ahead and cancel the x. Negative 3 over positive 3, what does that become? Negative 1. Good. You questioning me, Emma? You're questioning me too? It's like a... Can I cancel the x's? I can't cancel the x's. I can't. Well, you guys called me out on it. That's good. Good. Just doing it because it is so tempting. It's not enough to know how to do the process and cancel everything correctly. You also have to know when you're done, because oftentimes there will be things that look like you can still cancel, just like that. This is the final answer. Next page. Just simplifying. 3x plus 12 over 6x plus 24. I see lots of things I want to cancel. Can I cancel right now? No, because it's not multiplication, it's additions. Or wait a minute, what about this? This is a 3 times x, and this is a 6 times x. So can I cancel the x's? Or can I reduce the 3 over 6? Yes? No? Fundamentally, is the top, is the numerator, the entire numerator, fundamentally, is it a multiplication or an addition? It is an addition, right? It is 2 things added together, 3x and 12. One of those 2 things is a multiplication, 3 times x, but fundamentally that is an addition. And I cannot cancel because it's an addition, right? So we need to change the fact that it is an addition by answering this question. Are the numerator and denominator in factored form? No, they are not. So we need to factor everything. As usual, the first kind of factoring is the greatest common factor. What is the greatest common factor on top? 3. Fill in the parentheses. So we should get an x plus 4 there. Downstairs, greatest common factor is 6. Fill in the parentheses. What do we get? X plus 4. What is the fundamental operation on top? Is it addition or multiplication? This is now a multiplication. See how it's subtle, but the thrust of the operations have changed. In original form, it was a 3x plus 12. Plus was the fundamental part. Now it's a 3 times x plus 4. It's multiplication. And now we can cancel. So what can we cancel? X plus 4. It's carbon copy, top and bottom. What's left is numbers, and you can still reduce 3 over 6 just like you would have, for the last many years in your mathematical career. So what's this equal to? 1/2. That's the answer. It's pretty atypical for all the x's to disappear, but it can happen. But usually you'll have x's left. Okay, next one in the table here. Part C, 2 plus x divided by 2. If you see something that you feel like you can cancel, go ahead and cross it off and write down your answer. This one's quick, right? There's not much to do here. So whatever you can do, do it, and then write down your answer. I see 2s. I'm very tempted. Can I? No. One of the twos is ready to cancel. Which one is ready to cancel? One on the bottom, because the one on the bottom is not bothered by any additions or subtractions nearby. But the two on the top is immediately followed by a plus sign. It is not ready to cancel. So if I can't cancel now, then I need to factor. Can we factor the top? No. Can we factor the bottom? No. So what's the answer? It's already simplified. So I don't know. Then we use CBS, I think, for cannot be simplified. Okay, so that is that. Coming down here to number 7. It says consider the algebraic fraction x minus 3 over 3 minus x. What is the value of this fraction when we evaluate it for the values of x equals 10 and x equals negative 2? Let's just do them separately. So x equals 10. Upstairs we go 10 minus 3. Downstairs 3 minus 10, right? So down is a negative 7. Upstairs 7. So when we reduce, negative 1. Okay, fair enough. Let's do the same thing going back to the original fraction, but now we're going to plug in negative 2. So upstairs we go negative 2 minus 3. Downstairs it's 3. Yeah, it's going to become a plus. I'll write 3 minus negative 2. So upstairs is minus 5. Downstairs is positive 5. Altogether, negative 1. Hey, isn't that interesting? It was negative 1 both times. And in fact, whatever number you plugged into this guy, you were bound to get negative 1. And the reason is, all you're doing is subtracting two numbers, the same two numbers, but in reverse order. So whatever you get when you subtract on top, it's going to be exactly the same on the bottom, just the other sign. Yeah? And whenever you have that, what is the fraction equal to? It's negative 1. So we're supposed to now be able to look at something like this original thing here and decide, oh, this is that funny pattern where I'm just subtracting the same two things on top and bottom, but the order is reversed. And whenever we see that, we're now going to know from now on that we can cancel them as long as we say, hey, this becomes a negative 1. So we're going to see it in practice in just a second. So here is the more general pattern right here. A minus B over B minus A. If you happen to see exactly that pattern and only that pattern, you can cross them both off, but put a negative 1. This is the only time we're crossing things off that aren't exactly the same as each other. Every other crossing off we do, things are exactly the same. But here, we're looking for this one specific pattern, A minus B on top, same thing but reversed on the bottom. Cross them off, put negative 1. It needs to be a part of a multiplication. Yeah. So let's see it in practice here. So this one's kind of already written out, but we'll just follow along. Starting with this original fraction here, 64 minus x squared over that stuff. Can I do any canceling right now? It is not in factored form, so we need to factor. The top is a difference of two squares. So 8 and 8, x and x, plus and minus. The bottom is a 2 by 2 box. All the details are omitted here. You'll need to spend time factoring that thing with the box. But looking at this new factored version, do you see our pattern, A minus B over B minus A? It's kind of hard not to see it because those are the things that are circled, right? So 8 minus x on top and x minus 8 on the bottom. And so here's how it works in practice. You cross them off, but they're not equal to each other. They give you a negative 1. And so the way that we write that is right there. We just put a negative 1 right in front of the whole thing. And you can see both of those things have been canceled now. The 8 minus x and x minus 8, they're just not written anymore. But in their place, in place of both of them, it's just that negative 1 sitting in the front. And everything else is still left over. The 8 plus x is there. The x plus 2 is still there. Just a negative 1 in the front, and then 8 plus x over x plus 2. Questions on that? Okay, on the next page, let's take a look at this guy. What's nice about trying to simplify this one? It's already factored, right? That would always be the first step. Hey, this is a gift. So the question is, can we cancel something here? So first thing we're looking for is, do you see carbon copies? Things that are exactly the same on top and the bottom? The answer is no. So the only other thing is this new funky pattern with the a minus b over the b minus a. So do we see that? No? What about here? Is that the pattern? X minus 1, what would the partner of that be on the bottom if it were going to be this pattern? Would be a 1 minus x, which is not 1 plus x. In this one, we cannot do anything. It's for sure not equal to 1 because they're not exactly the same as each other. It's just, can we apply our new pattern? And the answer is no. The new pattern is really particular. It's got to be subtraction on both. So that 1 plus x is never going to be part of this new pattern. It has to be a subtraction. So there's nothing to do with this guy. And if you don't believe it, so here it just says, what if we just pick a number like x equals 7 and plug it in here? If it was going to be our pattern, we should get -1 at the end of the day, right? So when we plug 7 in, what do we get on top? 7 minus 1 upstairs is a 6. Downstairs, 1 plus 7 is an 8. It's not the -1 we were expecting. It's just a kind of random fraction, okay? So we can't do anything there. It's a really particular pattern. Okay, so what we have talked about so far has all been simplifying a single fraction. But now what we're going to do is take two fractions and multiply them and divide them, right? Those are the other two topics for today. So again, we'll remind ourselves how we did it with numbers, and then it'll be the same thing that we do it when we have variables floating around. So let's look at this example, 4/9 divided by 2/27. So someplace in your ancient math past, you had somebody that said, oh, the way that you divide fractions is you copy the first fraction, you change division to multiplication, and what do you do to the second fraction? You flip it over. Yes? Is this ringing a bell for folks? So the first fraction is copied here, division has turned into multiplication, and the second fraction gets flipped over. Instead of 2/27, it becomes 27 over 2. If you want to see why that's something reasonable, just ask me after class and I can show you. But I think this is something you've seen before. I mean, like you've got a lot of practice with fractions, even if we don't love fractions. You've done problems like this before. And then how do we, now that it's multiplication, how do we multiply fractions? Let's go straight across. But before we go straight across, we're going to always look for things that we can reduce. Promise it will make your life easier. So in this case, what can you reduce on top and bottom? I see a 4 and a 2. Can I reduce them? They're in different fractions. What allows me to cross them off? Because they're in different fractions. I'm tempted to say they've got nothing to do with each other. It's multiplication. In your mind, you know that you're allowed to multiply straight across. So in your mind, just visualize this whole thing as one big fraction, right? Straight across. So there's no two fractions. There's no, the 4 is in the first fraction and the 2 is in the second fraction, so they don't interact. It's just one fraction. And absolutely, you can cross them off. So we reduce the 4 and the 2, the 27 and the 9, even though they were in different fractions, doesn't matter. 27 and 9 becomes a 3 and a 1. So we just get 2 times 3 over 1. Questions on that? Okay. So that is how we divide, and embedded in every division of fractions is a multiplication. So that's addition, division and multiplication both together. So let's take a look at 11a. We've got this 15x to the 9y cubed times 2 over 35x to the 4y to the 10. So we're going to multiply. In order to multiply fractions, personally, I really like them both to look like fractions. So how can I alter this first guy? Over 1. Now it looks like a fraction. And so yes, we're going to multiply straight across, but before we do, we're going to look to cancel whatever is available to us. So do you see any numbers that cancel? Any number on top with a common factor with the number on the bottom? 15 and 35. What's the common factor? 5, right? Like we got to expand our view. It's not just like separate fractions. It's just one big fraction. So 15 and 35, when you reduce the 5 out, what's left from the 15? So 3 there and 7 there. So far, so good. Let's look at the x's. Upstairs, I see x to the 9. Downstairs, I see x to the 4. I'm going to write this here. I don't need you to write it for my purposes, but just to remind you, you spent a lot of time simplifying things that look like that. And that's this problem. What's our shortcut with those powers? Is to subtract them. So is it positive 5 or negative 5? Well, it depends on where you put it. Yeah, for me, I'd put 5 on the top. So this x to the 9th becomes an x to the 5th on the top. And the x to the 4th downstairs just becomes a 1, which I won't write. Go ahead and do the same thing right now with the y's. So upstairs there's y cubed and downstairs there's y to the 10. So what's left over when we reduce? It's y to the 7 where is in the bottom, because that's where there's more of them, right? So all of those y's get sucked into these y's and disappear, and you'll still have 7 y's left over on the bottom because there were more y's downstairs. Okay, so now that I've reduced as far as I can, I'm ready to do the easy multiplication straight across, which we never did before. So upstairs, I see a 3 times a 2, that's a 6. Copy the x to the 5th. Downstairs, 7 y to the 7. Done. Okay, next up is part B. Part B is a division problem. I know there's a hint over here. I'm actually going to ignore my own hint and do the thing that we had set up above. When we see the division of two fractions, what do we do with the first fraction? Leave it. So we're going to copy that first guy. 4y squared minus 1 over 4 minus y squared. Division becomes multiplication. And what do we do with the second fraction? So we flip it. So y squared minus 2y over 4y plus 2. Okay, now it's multiplication. You are welcome to multiply straight across, but you're going down a bad path if you do that, because the goal is to give me a simplified final answer, and multiplying straight across will give me a correct answer, but it won't be simplified, not by a long shot. And we actually don't have the tools to go get to the simplified version if you decide to multiply it out right here at the beginning. So instead, we're going to take the advice of this hint now. Let's just factor everything. So let's factor everything. So I'm just going to get my basic shell here with my two fraction lines. So 4y squared minus 1, I'm going to run through my same 3 factoring options. It's always the same 3 things and always in this order. Greatest common factor, what is it for those 2 terms on top? It's 1, so that's not helpful. Is it a difference of 2 squares? Actually, it is. It's 2 terms. There's a subtraction sign in between, and both of these guys are perfect squares. So we found our winner. What 2 things are going to give me a 4y squared? 2y and 2y. What's going to give me a 1 is 1 times 1. And then the signs, plus and minus in either order, right? That's the difference of 2 squares. Okay, let's go downstairs now. The 4 minus y squared. Same 3 questions in the same order. Greatest common factor is 1, which is not useful. Is it a difference of 2 squares? Hey, it is. So we're really getting a lot of play out of this difference of 2 squares formula. It's really nice because it's quick, right? 4 came from 2 and 2. Y squared came from y and y. 1 plus, 1 minus. It's always that pattern, and it's always quick. The long kind of factoring is the box, which is why it's the third kind of factoring you look for. Because if you can find something else to do, it's going to be quicker than the box. So the box is like the last resort. Not to say it's not useful. We use the box all the time, but it's not the first option to try. Moving to the top right fraction, or the top right expression. Y squared minus 2y, same three questions. What's the greatest common factor? It's y. Hey, we can factor that y out. So pull the y outside. What's in the parentheses? Y minus 2. And it's done. And I just want to point out that y squared minus 2y, for some of us, we just immediately think box. And the box will get you there, but it's going to take a lot longer than this. So there's a reason we ask these three questions in this particular order. It's the order easiest to hardest in terms of the process of factoring. Okay, downstairs, 4y plus 2. Same first question as always. What's the greatest common factor? 2. Anything other than 1, I get excited. So let's pull that 2 out. What's left when we pull the 2 out? 2y plus 1. Just like that, we're factored. We factored 4 things. How many times did we use the box? None. I think the box is great. I'm not saying anything bad about the box. I'm just saying ask the 3 questions in the right order and you will get to your answers as expediently as possible. Okay, now we're looking for things that we can cancel. So first, just want things that are exactly the same. What do you see? Where is it? Are they the same? Y minus 2 and are you saying exactly the same thing? Say the first thing here. Say the first thing here. Just say the first thing. Say the first thing. Are you saying the same thing? No, so these are not the same. We're gonna come back to it. There is something going on there, but it's not the easiest thing. The easiest thing is exact copies of each other. What do you see as exact copies? It's the 2y plus 1 and the 2y plus 1. So they just cancel. Are there any other exact copies? Something on top and bottom? The answer is no. But Evan has found the other thing we're looking for, which is this funky pattern, a minus b over the same thing, but other order. Y minus 2, 2 minus y. That's a brand new pattern. Cross them off, but you don't get to just cross them off without paying for it. What's the price? It's a -1. I didn't really give myself room here. I'm going to put a -1 in the front. Oh, let's try this again. Okay, so I'm paying the price with a -1 in the front. Okay, and then it's just a matter of writing our cleaned up final answer. This is just copying. -1 in the front, I'm just going to put the negative sign. And then I'm copying everything that's on top. I'm just going to leave it in exactly that order. 2y minus 1 times y. And then copying downstairs, 2 plus y times 2. And I see lots of things that are the same, so I want to cancel more if I can. You have to. If you're able to cancel more, you need to. So I see a y on the top and a y on the bottom. So for example, these two here. I cancel those? Nope. What about those two? No. One of those y's is ready to go. Which one is ready to go? The one on the top, because that's sitting next to a multiplication. But the y in the parentheses is firmly attached to addition, so I can't do anything there. What about some 2's? How about like this 2 and this 2? No good? Are either of those 2's ready? One on the top is next to a multiplication. Yeah, the 2 on the top is in parentheses, and the thing in the parentheses is a subtraction. So neither of those is ready to go. What about the 2 on the top with this one? The one on the bottom right is ready, but it has no partner. So we're done. Questions on that? Okay, so just 2 quick announcements before you jump to the activity on the next page. So one of them is about the final exam, which we said is coming up 2 weeks from today. It is not too early to start studying for that final exam because that final exam is on everything from the whole semester. and pretty soon it will be too late to start studying for the final exam. So we've got a window here in which you want to start studying as soon as possible. And it is far, far better. Suppose that you have like in the next 2 weeks, let's suppose that you're planning on finding like 10 hours to study for this final exam. And I'm hoping you can find that time. Is it better to do like 5 hours the day before and 5 hours the day before that? Or is it better to do an hour a day? Hour a day. It's much better. And if you can't find an hour a day, find 20 minutes a day. But slow and steady is far better for learning and retention and performance on tests than cramming. And cramming is not just all-nighter. Cramming is like doing marathon sessions for the previous few nights before the test. It's just not as effective. So you've got time now in terms of like there's 2 weeks left. Hopefully you can carve out a little bit of time consistently. That's the goal. In terms of resources for you on the final exam while you're taking the test, you're going to be allowed to bring in 3 sheets of paper. One of them is the Perfect Powers reference sheet. So hopefully you still have that. If you've lost it, I can get you another copy or it's on Moodle. The other 2 are going to be sheets of your own creation. Hopefully you saved one or both of the cheat sheets from the first 2 tests because you can use those again. Don't forget to add things related to fractions. All right. So my reference sheet with the powers and then 2 sheets of your own creation. Calculator for the whole thing. Okay. All right. So I also want to talk about the test, but I haven't handed the test back to everybody yet. So when we have 5 minutes left in class, I'm going to hand the test back to everybody and we'll talk about the test that we just took. Okay. Right now, let's see how far we can get with the fractions.